Hello everyone and welcome. Have you ever stopped to wonder how your email just knows what spam is? Or how a computer can get so good at a game like chess it can beat the world's best players? Well, today we're going to pull back the curtain on how machines actually learn, and you might be surprised at just how familiar it all sounds. It really all boils down to this one big question. And the answer, believe it or not, is surprisingly human. You see, computers learn in ways that are a lot like how we learn. By studying, by exploring, and yeah, by simple trial and error. So today, let's meet 3 different kinds of computer students.
Okay, first up, picture a student who's studying for a huge test. They've got a massive stack of practice questions, but here's the kicker. They also have the complete answer key. This is our first type of learner.
In the world of machine learning, this is what we call supervised learning. And it's called supervised for a reason, because we're the teacher. We give the computer a gigantic data set where all the answers are already labeled. We show it an email and say, yep, this one's spam. We show it another one and say, nope, this one's legit. We're guiding it the whole time.
So let's break that down. First, the computer just looks at thousands or even millions of these labeled examples. Then, after seeing enough, it starts to figure out the patterns on its own. It learns what kinds of words or features tend to show up in spam emails. And finally, when a new, unseen email arrives, it uses that pattern it learned to make a prediction, spam or not spam. It's just like you learning a math formula from example problems and then using it to solve a new one on the test.
So where does this kind of learning really shine? Well, it's absolutely fantastic for making predictions. That spam filter in your inbox? That's it. Websites that estimate a house's price based on past sales? That's it too. Even a bank using your history to decide if a loan is a safe bet. Anytime you have good historical data with clear outcomes, this student is a straight A performer.
All right, let's meet our next student. This one is completely different. Imagine handing someone a giant, messy box of Lego bricks, all different shapes, sizes, and colors, and you just say, organize this. No instructions, no picture on the box to follow. Just figure it out.
This is what we call unsupervised learning. Here, we give the computer a mountain of data, but with a twist. There are no labels, no answer key. Its entire job is to look at all this information and find the hidden structures all by itself. It has to become a kind of data detective, looking for clues and connections that we might not even notice.
So how in the world does it do that? Well, the computer sifts through all that unlabeled data and just starts detecting similarities. It might notice that certain things have similar features and begin to cluster them together into groups. You could think of it like sorting your laundry for the very first time. No one told you what whites, darks, and colors are. You just notice some clothes are similar and you naturally start making piles.
And this Explorer student is amazing in some really fascinating areas. It's perfect for things like grouping similar customers together for marketing campaigns, or for a store like Amazon to figure out that, hey, people who buy potato chips also tend to buy soda. And it's incredibly powerful for spotting something that just doesn't fit in, like an unusual credit card transaction that might be fraud. And that brings us to our final student. This one is a gamer. It doesn't learn by reading a rule book or studying examples. No, it learns by playing the game. It just tries a move, sees what happens, and then tries to do a little bit better the next time. It's all about learning from pure experience.
This method is called reinforcement learning. The computer, or what we call an agent, interacts with an environment. Whenever it takes an action that gets it closer to its goal, it gets a reward. Think of it like points in a video game. But when it makes a bad move, it gets a penalty. The entire goal is to figure out a strategy that gets the absolute highest score possible over time.
The learning loop here is so simple, but it's incredibly powerful. You take an action, you get feedback, either good or bad, and then you use that feedback to update your strategy so you make a better decision next time. It's just a constant cycle of trial, error, and improvement, but it's repeated millions or even billions of times until it becomes an expert.
And the results are, well, they're just amazing. This is the exact method used to train AI to beat the world's best players at insanely complex games like chess or Go. It's how we teach a robot how to walk on 2 legs without having to program every single tiny movement. And it's a huge piece of how self-driving cars learn to make split-second decisions in busy traffic.
So we've met our 3 students. The diligent studier with the answer key, the curious explorer who finds patterns in the chaos, and the adventurous player who learns from its mistakes. Let's put them all side by side for a final report card.
This table really puts it all together, doesn't it? You've got our first student, Supervised Learning, using labeled data with one goal, predict an output. Then you have our Explorer, Unsupervised Learning, working with unlabeled data just to find patterns. And finally, our Gamer, Reinforcement Learning, learning from pure feedback to maximize its rewards. 3 very different students with 3 very different ways of learning.
You know, when you step back, you realize we're teaching computers to learn in these fundamentally different, yet incredibly powerful ways. They can study the past, discover the present, and plan for the future. Which kind of leads to one final thought. If we've already taught computers to learn this much, what's the next lesson going to be? What will they learn to do next?